Hello and welcome back. This video is a request by one of you guys, one of my followers, and they asked me to solve some difficult questions from the topic moments. So as you can see, I've tried to pick some of the most difficult questions from this topic. You might have seen some of these questions in the past papers, and I'm very confident that by the end of this video, you will be able to solve these questions very easily. So to achieve this outcome, what I've done is I tried to break down this topic into simplest possible general concepts. So the interesting thing is that if I just tell you the definition of moments and how to apply, for example, the concept, you will not be able to solve these questions. But if I teach you some big concepts, general concepts, then you can apply those concepts on this topic, moments, and also on some other topics like Newton's laws and free body diagrams. You will be able to solve those questions also. You will be able to apply the same concepts in other topics. So that's the main and big idea of this video. I want you to see that it is always some simple concepts, some general concepts that the examiner wants to test you on. Okay, they don't care about just moments. They will always test some big ideas by asking questions about a smaller topic like moments. And the big ideas that you need to understand to solve this question from the topic moments. So the big ideas are just two. Okay, the first one is equilibrium and Newton's second law, and the second one is vectors. So any question that you will solve on the topic moments will either test you on your understanding of equilibrium, or the question will test your understanding of vectors. And if you understand these two concepts, then you can solve any question from moments. So let's get started. I've already written the notes here to save some time. The first topic is equilibrium. What equilibrium means is that under the influence of two or more forces, if the object is at rest or it is moving with constant velocity, then we say that the object is in equilibrium. Most of the students think that equilibrium means that the object should be at rest. This is wrong. It can also move, but it will move at constant velocity, right? So to get this state of equilibrium, which means at rest or constant velocity, it needs to satisfy these two conditions. The first one is that sum of all the forces should be zero. And the second condition is that sum of all the torques or sum of all the moments should be zero. So let's look at the first condition, sum of all the forces should be zero. On the diagram on the right side, you can see we have two masses on seesaw. The first mass is 1 kilogram, and that will make its weight 10 newtons. And I'm taking G as 10 meters per second squared. So 10 Newton is weight. And similarly, the weight of the second mass is 20 newtons. Now the question is, what is the force, upward force, exerted by this support? So if you can answer this, then good. You understand the first condition, sum of all the forces should be zero. But if you can't, I can explain it. What you have to see is that this seesaw is not moving in the y direction, right? So it means that the sum of all the forces in the y direction should be zero. So that's why we can see that in the negative y direction, downwards, we have total of 30 newtons acting downwards, right? That means that the upward force because of this support should be 30 newtons, right? So this is the first thing you will see in one of the questions also. We will have to apply this condition to find the force exerted by the support or one of the supports. So you should understand that, remember this, to find the force exerted by some support, you have to apply Newton's second law, which is sum of all the forces should be Newton's second law and equilibrium combined. Okay. For the first case, this seesaw will not move up and down, but it will rotate, right? So it will start rotating, for example, in the counterclockwise direction. So this seesaw is not in equilibrium right now. Okay. That's why I said that for equilibrium we have two conditions. If any one of these two conditions is not fulfilled, you don't have equilibrium. So to get or to achieve full equilibrium, we also have to satisfy this second condition, sum of all the torques or sum of all the moments should be zero. And for this example, now we have equal weight on both sides, 10 Newton and 10 Newton. And you can see that clockwise moment and the anti-clockwise moment, because of the same weight on both sides, will cancel each other. And now this seesaw will be in equilibrium, which means it will not have linear acceleration, and it will also have zero rotational acceleration or angular acceleration. It will neither rotate, neither move in straight line or anything like that. Also, just to remind you that the force exerted by this support here will be 20 newtons, because the downward force is 10 plus 10, 20. So the upward force will be 20 newtons. Okay, I hope this is clear. Now, the second concept is more complex, and this is vectors. So for vectors, we also need some review. You might remember this from trigonometry in your GCSEs. So if you have a right triangle, you can, for example, get a relationship between adjacent side, opposite side, and hypotenuse using these identities, right? There is also a mnemonic to remember these identities, and mnemonic is SOHCAHTOA, right? So SOH is sine of theta equals opposite divided by hypotenuse, or opposite or hypotenuse. So, and CAH is cosine of theta will be equal to adjacent over hypotenuse, so cosine adjacent hypotenuse, and tan of theta will be opposite over adjacent, right? So tan opposite adjacent. SOHCAHTOA. But these identities only apply if you have a right triangle, which means one of the angle is 90 degrees. And you have to be careful. The way we name these sides, adjacent, opposite, and hypotenuse, is always in reference to the angle that you are given. In this case, if this is the angle that's given, you know this angle, then the side which is opposite to this angle will be called opposite. The side which is adjacent to this angle will be called adjacent, and the side that is opposite to the right angle, 90 degrees, this is hypotenuse. But on the other hand, if let's say this angle is given instead of this angle, let me draw it in different colors. So this red angle, if the red angle is given, then this side which I've written here, adjacent, this will become opposite. This side opposite will become adjacent, and hypotenuse will remain hypotenuse because it is opposite to the right triangle, or sorry, the right angle. This will not change. So I've seen most of the students making mistakes because of this thing, that in some of the diagrams, because the angle is different, they always use these same identities, and they forget that the angle they are using, if the angle is different, the sides will also change. So you have to be careful with this. This is just review. If you understand this, or if you remember this, good for you. Let's see if you can apply these things on vectors. So I have here two vectors, A and B, and my question is that you have to find B perpendicular. This symbol here is B perpendicular, which means that I want you to find component of vector B which is perpendicular to vector A. And second, I want you to find B parallel, which is this thing, and B parallel means the component of B which is parallel to A, right? By B perpendicular, I mean that you have to find this component of B, right? You can see this component is perpendicular to A, so we will call it B perpendicular. And the second one, B parallel, will be this component right here, this one, and this component will be B parallel. Now, if you are smart, you can see that we have here a right triangle. So we can apply all of these concepts on this right triangle. This is the right triangle, right? So what we need actually is an equation for this side. And you can see now this B perpendicular is the opposite side of this angle. So this is actually opposite. And this B parallel is the adjacent side of this triangle. So what I'm asking you is basically to find opposite side and adjacent side in terms of B and this angle theta. So this is very easy now. You can look at the equations here on the right side. So in order to find opposite side, we can use the first equation. And if you rearrange it for opposite side, you have to multiply hypotenuse on the other side. So we can write it here, B perpendicular will be equal to hypotenuse times sine of theta. Hypotenuse is, in our case, B. So it will be B sine of theta. So this equation is actually opposite equals hypotenuse times sine of theta, which is basically this equation just rearranged for opposite side, right? For the second one, B parallel, you can see that B parallel is adjacent side, right? So we have to use this second equation to and we have to rearrange it for adjacent. So it will be equal to B times cosine of theta. And again, this equation is just that adjacent equals hypotenuse times cosine of theta, which is just a rearranged form of this equation which we have here. Now again, I want to remind you that you should not connect b parallel with cosine theta and b perpendicular to sine of theta. This is not true. A lot of students make this mistake. They say, okay, the perpendicular side is always b sine of theta, and parallel side always uses cosine of theta. They don't look at the geometry or the angle which is given in the question. As you will see in the questions that we solved today, the opposite side or the perpendicular side will use cosine of theta because the angle will be different. So I cannot stress this thing enough. Do not connect perpendicular with sine theta and parallel with cosine theta. What you should remember in general are these results, which I've written here. This is always true, but which side is opposite, which side is adjacent, which side is hypotenuse depends on the question. So just remember this, because when we start solving the questions, I will ask you to find the perpendicular component or parallel component, and then I will see if you use the right equation. Okay, so you will be tested on this concept in a moment. So this caution sign is the same thing I was talking about. I wrote it so that I don't forget to explain this thing, that do not connect perpendicular to sine theta and parallel component to cosine theta. This is not true. This will not always work, as you will see in one of the questions. Okay, next, now you must be thinking that we have to understand moments. Why are we talking about vectors? And the reason is that moments or torque is just the cross product or vector product of two vectors, right? So here I will write the definition of moments. Moments or torque is the cross product of two vectors, and the two vectors are r and f. So what is r? What is f? R is the moment arm and f is the force. So if you have, for example, some screw here and you have a wrench, you apply some force here. So the moment arm will be the distance from the point where the force is acting to the point, to the pivot point about which this thing is rotating. This is r and this force is f. Now in a minute you will see that this is not always as simple as this, and that's why understanding of vectors is very important. For now, just the definition of torque. Just remember that r is the distance from the pivot point to the point of action of force, and f is the force itself, and torque, which is this symbol here, or moments, is the cross product of these two vectors. Now what is cross product? To understand definition of vector product or cross product is, if you have two vectors a and b and you have to take their cross product, what you have to do is you have to multiply the perpendicular component of the second vector with the first vector. So a times b perpendicular. So now you can see that why I spent some time to explain how to find this b perp or b perpendicular. So now you can use the definition of b perpendicular, which sometimes is just b sine theta, but like I just explained, this is not always true. That's why you should not remember this thing. What you should remember is this thing. So cross product will always be a times b perpendicular, but the definition of b perpendicular will not always be b sine theta. Sometimes it will be b cosine of theta, depending on the angle that is given. Okay, so that's why this is not general. This is general, and the concept that you should remember. Cross product of AB is always A times B perpendicular. We also have this property of cross product or vector products, which is relevant to this concept of moments. There are also other properties of cross product, but this one is particularly important in reference to this topic. And the property is that the cross product of A and B is not the same as B cross A, but it is actually minus B cross A. What it means is that the direction will be opposite because of this minus sign. So if A cross B is pointing upwards, B cross A will be pointing downwards. Okay. Now, what can you conclude from this thing? That if A cross B and B cross A just differ by a minus sign or a direction, it means that the magnitude of A cross B will always be equal to B cross A, right? So this result is also important because, as you will see, we will use this property in the questions. So if the question is not asking you about direction of torque, you can just use A cross B, or you can use B cross A, because one of these will be easier than the other. So depending on the question, sometimes it will be easier to calculate A cross B, and sometimes it will be easier to calculate B cross A. And if the question is not sign sensitive or direction sensitive, or if you can just see the direction from the diagram, then you should go with the easier one, the one that is easier to calculate, A cross B or B cross A, because the magnitude of both of these will be equal. Okay, so the moment of truth. Now we have to apply everything that we learned to solve this question. So what we have here is a basketball post, and the question is that we have to calculate minimum force of the wind Fw that will cause the basketball set to be blown over when it is at an angle shown. Ignore the effects of the wind on the base. Weight of the post arrangement is also given. So let's look at the diagram again. We have wind of the force here, Fw, and weight of the post acting straight down, and we have weight of the base acting here, and all of this system is balanced on this point, right? So the first question, where is our pivot point? This is our pivot point, right? So the whole thing is rotating about this point. So this is our pivot point. We want to come up with a strategy to solve this question, right? And again, you will see that we will apply just these two concepts, equilibrium and vectors. We have to find the minimum force that will cause the basketball to be blown over when it is at an angle shown. So if the whole system is balanced, right, then it will not fall. And if it is balanced, it means that the clockwise torque, as I explained, for balanced condition, total clockwise torque should be equal to total anti-clockwise torque about this pivot point. This is our pivot point. So this will be our condition for equilibrium. For equilibrium, we need sum of all the torques, or sum of all the moments about this pivot point, to be 0, which means that all the counterclockwise moments, CCW, plus all the clockwise moments should be 0. You should also remember that clockwise moments are always taken as negative and counterclockwise moments are taken as positive, right? Just like forces, if you have a force acting upwards, we call it positive, and if you have a force acting downwards, we take it as negative. Same is with these moments. So when you're adding these two, you have to take this into account, and you should write negative sign with clockwise moments, and this should be 0. If you rearrange this equation, you should have that counterclockwise moments should be equal, just move this to the other side, it should be equal to counterclockwise moments should be equal to clockwise moments. So we got this result by just applying the first concept that we learned, right? Equilibrium. Now we will use the second concept, that is cross product, to calculate these moments, right? So to calculate counterclockwise moments, we need to see how many forces are acting to rotate our system in the counterclockwise direction. So we have force of the wind and weight of the post arrangement. Both of these forces are trying to rotate the system in counterclockwise direction. So we have two moments. The first moment is because of Fw, force of the wind, plus we have weight of the post arrangement. So because of the weight of the post arrangement, Wp, and how many torques, or how many moments, or how many forces are trying to rotate the system in the clockwise direction. We have only one force which is trying to rotate the system in clockwise direction, and it is weight of the base, right? So we will calculate moment because of weight of the base, Wb. This is weight of the post, this is weight of the base. Okay, now we apply the definition of moments, which is cross product of R and F. I hope you remember here. So where is R? For Fw, force of the wind, R is just the distance between the point of action of force and the pivot point. So this is R for Fw, and for weight of the post, R will be this distance, because the weight is acting here, and R is always the distance from the point of action of force to the pivot point. So just remember this. I will write these things as variables right now. So I'll write R for force of the wind times, or cross product with force of the wind, Fw. I'll write Rw. So this is just this quantity, moment because of the force of the wind, plus moment because of the weight of the post. It will be moment arm R for weight of the post. I'll just write it Rp, and cross product with force of the weight, force because of the weight of the post arrangement. So F, I'll just write Fp, and on the right side, that is clockwise moment, we have moment because of the weight of the base. And you can see for weight of the base, R, which is our moment arm, will be the distance between pivot point and the point of action of force, which is this distance. It is also given, but I will write it as R of base, moment arm of base, cross product with the force of the base acting on the base, which is just the weight of the base. Okay, so this is our condition for equilibrium. Okay, remember that we started with the condition for equilibrium, and if this side, left hand side, is equal to right hand side, we will achieve equilibrium. But if, let's say, the left hand side is just a little bit greater than the right hand side, then the post will topple to the left side, right? So our strategy or our plan is to start with this equation for equilibrium and solve for Fw, force of the wind that is required for equilibrium. And then we can say that the minimum force will be slightly greater than Fw. So Fw, let's say we get 10 newtons for Fw if we solve this equation. So you can write that if Fw is slightly greater than 10, let's say 10.1, 10.2, then the whole system will topple to the left side. So this is our strategy, okay? Now comes the interesting part. How do we calculate these cross products? So let's start with the first one. I will name these three cross products. This is, let's say, 1, this is 2, and this is 3. So I cleaned this diagram because we need to draw some vectors, and I want you to see clearly what we are doing here. So Rw is, I will choose red for it. Rw is this distance, and Fw is this, right? Which is acting in this direction, you can see here. Now, if we follow the definition of cross product, that is, the cross product of A and B is defined as A times the perpendicular component of the second vector multiplied with A. So in our case, we have Rw cross Fw, which means we need Rw times Fw perpendicular, right? Rw is given, and we need to find the perpendicular component of Fw. And what is the angle between R and F? The angle is this. So this is our angle between R and F. Now, this is the point where we have to use this property that I explained, that if you are just interested in calculating the magnitude of A cross B, you can either use A cross B or you can use B cross A, depending on the question, right? So if you look at this question right now, you will see that if you try to find F perpendicular, that is the component of F which is perpendicular to R, which is kind of difficult to see here, right? I'm sure if you try to find it, you will find it very difficult to find the component of F which is perpendicular to R. I will also show you how you can find it, but you will see that it is very complex. But you can also find Fw cross Rw. And in this case, what you have to find is the magnitude of this will be equal to the magnitude of this one. What you have to multiply is you have to multiply R perpendicular to F, right? So the perpendicular component of R to Fw, which is very easy. So you see F is pointing straight in the X direction. So if we draw our X's here, bad color choice, maybe black. So if this is our X's, you can see that F is pointing straight in the negative X direction, right? So this is the direction of F. So the component of R that is perpendicular to the direction of Fw will be this component right here, starting from here. Oops. starting from here straight to the x-axis. You can see that this is r perpendicular. You see how easy it is? This component of r is making 90 degrees with the direction of f. So if you just find r perpendicular and multiply this to fw, you will get this result for 1. Now let's see what is r perpendicular. Now you will see that we are using everything that we learned here. You see we have a right triangle here. This is our right triangle, and this is our angle. So this is what I was talking about, that you will see that the perpendicular component is not always sine of theta. Sometimes, because of a different angle in the diagram, the perpendicular side is actually adjacent of this right triangle. You can see this is angle, and this side is opposite side, but this side, the black one, is adjacent. And because adjacent, you can see here, adjacent is always hypotenuse times cosine of theta. So we can find RW perpendicular, which is adjacent side. We can use FW, which is just FW. And for this guy, RW perpendicular, we can use hypotenuse, which is just R, this distance. Hypotenuse times cosine of theta. So cosine of 15 degrees, but I'll just write theta. And that's it. So R perpendicular in this case, because it's adjacent, will be equal to R cosine of theta. So that's it. This is 1, right? FW, by the way, you will not get an answer for this because FW is what we are trying to solve for, right? FW is unknown. But that's the idea. Once you have everything, the full equation, you have to rearrange the final equation for FW. So this whole thing will go on the other side of the equal sign here in this equation. And that's why it's always a good idea to not substitute any numbers from the start. Once you have the final equation rearranged for FW, only then we will substitute all the numbers. Okay, now just for completeness, I also want to show you that we can also get the same answer if we use the first equation, that is R cross product with F, not F cross product with R, okay? So if we were to use the first equation, R cross F, what you need to do is you need to draw your axis, or you need to extend this R vector here like this. So this will be R. Now you can resolve F on vector R, and you can see that it will look something like this. And you can see this component is F perpendicular because it's making 90 degrees with the direction of R. And we have to find this component. But you see that it is very complex because you have to find this angle theta in reference to this angle theta. In this case, it will be 15 degrees. From geometry, you can confirm that if you rotate it in different ways, if you use different identities, that this angle, 15 degrees, and this angle, they are the same angles. And again, this side, you can see that this is not the opposite side, this is the adjacent side of this angle. So it will again, F perpendicular will be F cosine of theta because it is adjacent side. And if you substitute F cosine theta here, you will see that from this side, you also get the same equation, which is RW magnitude, FW magnitude times cosine of theta. And this is the same as this equation. So once you have written R in terms of cosine theta and F in terms of cosine theta, these are just magnitudes. So it doesn't matter if you write R first and F second, or if you write F first and R second, you have these as magnitudes now. So, and theta is also the same. So you will get the same answer from both of these. But what I want you to see and remember and understand is that one of these guys was easier to calculate or to see than the other, right? So this one was easier, this one is difficult. And to choose between difficult and easy, you have to remember this thing, that if there is a question which does not depend on this negative sign is not that important here, then you can use either this result or this result depending on the question. If you don't remember or understand these general concepts, then you will again get stuck in another question. If I, for example, change the diagram, if I change the question statement, and if you don't remember this thing, this big idea, or this understanding of vectors, which is what examiner is testing you on, right? So they are testing you on this understanding that you can use any one of these two depending on the question, as long as the direction is not important. So if you understand these big ideas, then you can apply these ideas on any question on moments. Now you can see that if I just had told you the definition of moments, r cross f, what is r, what is f, you cannot solve this question, right? It doesn't matter how many times I teach you the same concept, moments, you will get stuck in the next question. But if you learn the general concepts, the big ideas, you can apply the concepts on any question. Now, as your test, I want you to solve this cross product number 2. So for number 2, r, the moment arm, will be again the same distance between the point of action of force and the pivot point. So this distance, this is r. It is given, you can see here. And F is the weight of the post arrangement, which is also given in the statement. It's 27 newtons. And you can see the angle here will be this angle between these two vectors. So again, you have to look at the diagram and you have to figure out which one is easier to calculate, r times f perpendicular or f times r perpendicular. And if you said the first one is easier, then congratulations, because I also think the first one is easier, because you can see that f perpendicular will be just this component of force, which is acting straight down. But this component, you can see it is at 90 degrees with the direction of r. And also this component, which we'll call f perpendicular, is, you can see this time, this is the opposite side of this angle or this right triangle. So it will not be cosine of theta. It will be equal to f times sine of theta, because this is the opposite side. And what is this angle? You can see again from using geometry that we also have a line here, a reference line here. This angle and this angle, they are equal. So this is the same angle as this one, 15 degrees. And the answer is that number 2 is simply r magnitude times f magnitude times sine of 15 degrees. And that's it. But be careful, you have to use different numbers here. This is rp and this is also fp, which is weight of the post, and rp is moment arm, which is different from r that we used in the first one, right? Rw is this distance, which is 2 meters plus 0.4 meters. Okay, and finally, for number 3, let's quickly look at what r is. So r is the distance from pivot point to the point of action of force. And again, I want you to figure out which one is easier to solve, r cross f b or f cross rb, which is fb times r perpendicular. The first one will be r times f perpendicular. But you have to be careful, because a little catch in number 3 is that you are not given this angle. But I hope that you can see that this angle will be the same as this one, because the whole system is rotated. So if you have, like, for example, a coordinate system and I rotate the whole thing like this, so the angle by which I rotated the y-axis is the same by which I rotated the x-axis, right? So this is my initial. So this angle and this angle, they will be the same because I rotated the whole thing. And now I will leave it as your homework to solve this number 3, because if I do everything, then this video will be 2 hours long, I think. So once you calculate everything, that is 1, 2, and 3, you will have a big equation, and then you just have to rearrange for fw. And if I do it here, you will see that you will have something like rf cosine of theta for the first one, plus you have r, these are different r's and different f's, times sine of theta for number 2, and you will also have something here. And then you just rearrange this equation for this fw. So for this, you need to move this to the other side. It will change the sign. So it will be rw fw cosine of theta equals to this guy, number 3, minus this guy, number 2, if you move it to the other side. And then you just need to divide by rw and cosine theta. So it will be fw equals number 3 minus number 2 divided by rw and cosine of theta. And that's it. This will be the force that will keep everything in equilibrium. Okay, don't forget this. the minimum force required to topple the whole system will be slightly greater than this force Fw. Okay, this next question, the dino question, this is also very famous. I've seen some students asking question on different forums about the dino question, and this is quite famous in terms of its difficulty. So let me tell you what I will teach you in this question, okay? I don't want you to set wrong expectations. I will teach you to develop a strategy to solve this question, okay? And similar questions. I want you to learn how to think, not how to rearrange equations and do algebra, right? That what's math teacher would teach you. What I want you to understand is the procedure or the kind of strategy or the kind of thinking you need to convert all of this thing, which is in English, into math, right? So how can you read this thing and write an equation? Once you have an equation, you can just do algebra, rearrange here and there, and you can solve for anything you want. The main problem in this question, the main thing that they are testing you on is, again, your understanding of these two concepts, equilibrium and vectors. They are not testing you on if whether or not you can rearrange the equation. You have no equation to start with, right? So just writing the equation will get you 2 or 3 marks. So let's read the question first. We have a, okay, I'll not read the question. You can read it, but I'll just explain. The question is that we have this force acting at tooth, which is 6,500 newtons, and not force acting at tooth. We have this jaw closing in such a way that the force exerted by this tooth is 6,500 newtons. This whole jaw, lower jaw, is rotating about this point P, which means this is our pivot point. The question is basically asking to find this muscle force that will make the force exerted by this tooth 6,500 Newton. So we have to find this muscle force, which will result in a force at this point having a magnitude of 6,500 newtons. Now I want you to stop the video, read this question, and come up with a strategy or come up with an equation that you can work with, right? This is the main challenge of this question. And I will give you my version of how to think about this question, and then you can compare your answer to mine. So it took me like 5 minutes to think about how can I explain this question in the simplest way possible, right? And I can try, but I don't know if I succeeded to make it simple. Here is my version of the question. The question is asking that this lower jaw, when it rotates, it will produce a moment about this point P. And this moment can be produced in two ways, right? We can either use this muscle force, or we can imagine that there is a force acting here at this point X, which can also rotate this jaw in this direction, right? So what the question is asking basically is to find the muscle force for which the moment produced by muscle force becomes equal to the moment produced by this force. Let's call it Ft, force acting at the position of tooth. If you can understand this equation, this simple equation, then congratulations, you understand my strategy, my plan to solve this question. If you're still confused why this whole statement is equivalent to this equation, then you should pause the video, think about it. You can ask in the comments. But basically, these bunch of lines, all it is saying is this simple thing, that find the force, the muscle force, which makes the moment of this lower jaw equal to the moment of this same lower jaw because of a different force which is acting at position X. The rest of the question is just expanding this simple equation, okay? So you see, again, we are using the same general concepts and we are applying it on different questions. This is the message that I want to give you in this video. If you just learn the definition of moment, if I change the question, if I change the diagram, you will get stuck again. You will have no idea where to start. But if you really understand the big ideas, the general concepts, then you can solve any question. So do not try to look for shortcuts. if you are learning something, learn it properly. So to solve the whole question, we just have to expand this simple equation and find the force of muscle for which this equation is true. Okay, let's expand the left hand side. Moment because of the muscle force is defined as moment arm of the muscle force cross product with force of the muscle, and it should be equal to moment arm for this force acting at x, let's call it RT, cross product with F acting at point x, which is FT. But I hope you're not thinking just to rearrange this equation for Fm, because this Fm is in cross product with R. This is not simple multiplication, which means you have to apply the definition of cross product. So R cross F is defined as Rm magnitude times Fm perpendicular component of Fm multiplied with Rm, right? So notice again that I did not write Rf sine theta because it is not general, but what I've written here, R times F perpendicular, this is always true. But F perpendicular itself can be F sine theta or F cosine theta, depending on the question and the angle that is given. Okay, on the right side, similarly, we'll have RT magnitude times FT, and again the perpendicular component of FT. But we don't have to worry about this right hand side, because if you see, FT is already acting, all of it is at 90 degrees with this R for this force, right? So this is RT, and you can see that this FT is, all of it is acting at 90 degrees with RT. So you don't have to worry about cosine theta or sine of theta on the right hand side. But on left hand side, you can see that muscle force is acting at this angle. What we need in cross product is not this muscle force. What we need is the perpendicular component of this muscle force, right? So we need this force right here, and we will call it F muscle perpendicular. And as you can see in this triangle, again, this is right triangle, so we are using our same what we learned about right triangles, SOHCAHTOA. This is actually the opposite side if this is angle theta, right? So you can see this is opposite side, and because this is opposite side, we will use sine of theta. So this will be Rm times Fm times sine of theta, and it will be equal to RT and FT. And now you just need to rearrange this equation for Fm. And Fm will be equal to RT Ft divided by Rm sine of theta. And this will give you your final answer. So you see, in the end, we just had to expand a simple idea, and in the end, we just rearranged the equation to get our answer. What students do, they focus on this part right here. So all of these equations, how will you rearrange the equation to find something? Basically, the algebra. What they don't understand is the question or the understanding you need to develop is to focus on this part, how to read these sentences in English and write this equation. You see, it looks nothing like this question. So this is the skill that you need to develop, okay? To convert a word problem into an equation. And then once you have an equation, you can just apply algebra to solve it. Okay, one more thing. They tried to make this question a bit more difficult by giving you this thing, that the skull is drawn to a scale of 1 to 10, which basically means that 1 centimeters in this diagram is actually representing 10 centimeters in reality, right? So what you do is to substitute these numbers, RT, FT, RM, and sine theta. You have to take measurements from this diagram. So when you measure, let's say RT, which is this length, whatever length you measure with your scale, let's say you measure 6 centimeters, so you have to multiply this with 10 to get the real value for RT. So in reality, it will be 60 centimeters. Similarly, you need Rm, which is the moment arm for the muscle force. And again, by definition of moment arm, it is the distance from the point of action of force to the pivot point. So this is Rm. And let's say if you measure 3 centimeters or 2 centimeters, then you have to again multiply it with 10, and it will be 20 centimeters. And this angle also, you have to measure with a protractor or something. You can measure this angle. I think it looks about 60 degrees. So it should be close to 60. And if you have all these numbers, you can just substitute here in this equation, and this will give you force of the muscle. Also, I hope that you can see that this Fm once, so this Fm perpendicular was this side, right? But once I write it as Fm sine theta, this Fm is this side. This is Fm. Because if you remember, opposite side equals hypotenuse times sine of theta. And hypotenuse in this right triangle is this Fm. So when you rearrange this equation for Fm, this Fm is this side, not this side, okay? So this is the perpendicular side, but by definition, perpendicular, or sorry, opposite equals hypotenuse times sine of theta. So this Fm, this is hypotenuse. This is, I'll just write opposite. So I hope this thing is clear. We wanted to find this Fm, not this. That's why we rearranged this equation for Fm. Next, we have this question. And first of all, congratulations, because the most difficult questions we have already solved. The rest of the questions are simple compared to the first two, right? So if you understood the first two questions, I'm sure that you will find these questions very easy. The first question is, show that weight of the plank is about 250 newtons and mass of the plank is given. And you can see it has only one mark. It means they just want us to convert mass into weight. We know that weight equals mass times gravity, so acceleration due to gravity. So it will be 25 kilograms times, we will take g as 10, and this will give us 250 newtons. That's it. The second question is the main question related to our topic moments. Determine the force exerted by the wall on the plank. So they are talking about this force that the wall is exerting on this plank. Okay, another thing that you have to use very often in questions related to moments is weight of something, right? Weight of the plank, weight of the swimming, what is it called? Jumping board. So weight always acts at the center of a regular shaped object. So if it is a rectangle, you can always assume that weight is acting at the center. So we have this force that we just calculated, 250, acting at the center of gravity, and we have force of the wall acting in the opposite direction as support. And because the whole system is in equilibrium, we can apply our understanding of equilibrium to solve this question, which is we have to calculate the moment about this point, and if we add all of our clockwise moments and all of our anti-clockwise or counterclockwise moments, they should be zero. They should add up to zero. So which force is producing clockwise moment? You can see that weight is trying to rotate the system in clockwise direction, and this support or force of the wall is trying to rotate the system in counterclockwise direction. So we will use our equation that because the whole system is in equilibrium, it means that sum of all the torques should be zero, which means that moment because of the wall, W, plus moment of the weight force, this is also W. So I will not write it as weight, I will just write it as mass, M, and they should add up to zero. And remember, I explained that clockwise moments are taken as negative, so you have to change this sign and write minus here. So it means that if you rearrange this equation, torque because of the wall should be equal to torque because of mass or weight force. I'll just write mg maybe. Okay, and now you just expand this equation. So torque because of the wall will be r cross f of force of the wall. This is also moment arm for the force that is being exerted by wall, which is this distance, this one, and this is rw, and this distance is r of mg. Okay, and similarly our torque or moment because of mg will be rmg cross product with fmg. And now you can see that in this case we don't have to worry about vectors or vector products because both of these forces are at 90 degrees with r, right? So F is also making 90-degree angle and W is also making 90 degrees, and sine 90 is just 1. If you apply the rules or try to resolve it, you will get 1. So you just multiply these two, and because we have to find force of the wall, we can just rearrange this equation. Force of the wall will be equal to Rmg times force of the plank, which is just weight. So I'll just write weight and then divide it by Rw. So Rmg is, I think, you can just divide this length in half. So this will be 2.5. This is what Rmg is, 2.5. And for Rw, you can subtract this length, 1.4, from total of 5. This will give you Rw. And weight is 250. So that's it. You can easily find Fw. The second question is again very similar. You have to apply the same concept. We have a bunch of different forces, and the first question is calculate the magnitude of forces P and Q, and they want us to take moments about point X. So where is point X? This is point X. And where is P? This is force P. This is force Q. And we have weight of the bridge acting here. And we have force from lorry acting at this point. So you can see that in the statement, they have given us weight of the bridge is given, force from lorry is also given. So these two things are known. Their moment arms, or R, are also given. So you can just use this distance. This is R for the lorry, force of the lorry. So you have to add 25 meters to 35 meters, and this will give you total R for weight of the bridge. And for force Q, R will be this total length. This is R for Q. And that's it. You just apply the same equations. But the main reason I included this question, so you see this force P, one of the forces that we have to find is force P, which is acting at the pivot point. You have to remember that when you're writing an equation for equilibrium, which is sum of all the torques should be 0, in this equation, you don't take the torques which are being produced by the forces which are acting at the point of rotation or at the pivot point. So if some force is acting at the pivot point, because R will be 0 for this moment, so you cannot really find force P by solving this equation. Using this equation, what you can solve for is force Q, right? So the question is how will we find force P? And the answer is you will use this very first thing that I explained. This thing, sum of all the forces is also 0, right? Which means if you have a bunch of forces acting downwards and bunch of forces acting upwards, they should be equal. So once you have all the forces for this question, so you have one upward force Q and two downward forces, weight of the bridge and weight of the force of the lorry. You have another force Fp acting here. It is acting upwards, and what you should have is sum of all the forces should also be 0. Now in this equation, you can include all the forces, even the forces that are acting at the pivot point. But in this equation, you cannot include the moment that is being I should say there is no moment because of the force acting at the pivot point. If there is some force acting at the pivot point, you just ignore it. You cannot write it in this equation. But in this second equation, you have to count all the forces and make sure that you also take into account the force that is acting at the pivot point. So if I expand this second equation, what I will get is sum of all the upward forces. So force of Q plus force at P, these two are upwards, minus weight of the bridge minus weight of the lorry should be equal to 0. If you just rearrange it for FP, FP will be equal to weight of the bridge plus weight of the lorry, and this FQ also has to go to the other side of the equal sign, so it will change sign. This is plus here, it will be minus FQ, and this will give you FP. So I hope everything is clear. FQ you can find by solving this first equation, which is sum of all the torques should be 0 about point x. Once you have Fq, then you can use the second condition of equilibrium to find Fp. Okay. The second part of this question is explain why force Q increases as the lorry moves across the bridge. I don't know why they have assigned 5 marks for this question. So as the lorry moves across the bridge, so initially it is here, and as it moves in this direction, this Fq will increase, and the reason is that the moment arm will increase, right? So the moment arm for weight of the lorry, if the lorry, let's say it's here, the moment arm, which was initially this one for lorry, now it is this one, right? So now the lorry is producing a much bigger clockwise rotation, and consequently this support column, it has to provide a much bigger support to counteract this clockwise rotation by this anti-clockwise rotation or counterclockwise rotation. So that's why force for acting here should it will increase as the lorry moves forward. The next question, again exactly the same concept. Now the reason I include this question is again to emphasize that you should not forget to use this condition in questions related to moments. You have to apply this condition in some questions to find some forces. So you see, we have weight of the book. Is it given? Yes, weight of the book is given, 8.5 newtons. Weight of the shelf is also given. Weight of the book will be acting here, 8.5. And weight of the shelf, like I just explained, it always acts at the center of gravity. So it will be acting here. It is 14 newtons. And now if you want to find the forces because of these two brackets A and B, you can apply simple Newton's second law. Sum of all the downward forces should be equal to sum of all the upward forces. The upward forces are normal force because of A plus normal force because of B. Again, these two will be positive because they are acting upwards, minus weight of the book, which is 8.5, minus weight of the plank or shelf, which is 14, and this should be equal to 0. You can just rearrange this equation, and because this thing is given that the normal forces acting on each bracket on the shelf are equal, it means NA and NB are equal. I can just write it as N, and then I can add these two N's. I will get 2N equals 8.5 plus 14, and then I can find the normal force because of each bracket, which will be 8.5 plus 14 divided by 2. So once you have the normal force, then you can solve this question. Determine the distance of bracket B from the left end of the shelf. So you have to find this distance from the left end. Now to solve this question, you have to take again moments because of different forces. So if you, for example, consider moments about this point, let's call it point X. So there will be two forces that will produce clockwise moments. One will be weight of the book. The second force will be weight of the shelf. These two forces will produce clockwise moments. This support force, normal force, will provide counterclockwise moment. And if the whole system is in equilibrium, then these two or sum of all the moments should be 0. So I included these questions so that you have something to practice. So everything that we learned, try to apply it on this question. This is very simple. And again on this question also. So these questions, after the first two, you can see the pattern now. The first two questions are more focused on this concept, vectors. And the questions after that, all of these questions are testing you on your understanding of this concept. So that's why I said that if you just learn these two concepts, then you can be sure that you can solve any question from this topic, moments. So I hope this was helpful and you learned something. The message that I want you to take away is again, focus on big ideas, general ideas that always work, not on the details. Okay, the details can change. If I change the question, if I change the diagram, sometimes you will have to use sine theta, sometimes you'll have to use cosine theta. So don't focus on details, learn the general concepts so that even if I change the question or change the statement, change the diagram, you will still get the right answer.